The moons of Mars, Phobos and Deimos, are two of the most enigmatic and fascinating objects in our solar system. These tiny, irregularly shaped bodies have puzzled scientists and space enthusiasts for decades. But what makes them so mysterious? Why do they look so different from our own moon? And what secrets do they hold that could change our understanding of Mars and its history? Strap in, because we're about to dive deep into the shocking, emotional, and mind-blowing story of Phobos and Deimos, the moons that could hold the key to unlocking the secrets of the Red Planet. Let's start with the basics. Mars, the fourth planet from the Sun, is home to two moons, Phobos and Deimos. These moons are tiny, so tiny that if you were to place them next to Earth's moon, they'd look like mere specks of dust. Phobos, the larger of the two, is only about 22 kilometers in diameter, while Deimos is even smaller, measuring just 12 kilometers across. To put that into perspective, their surface areas are comparable to some of the smallest countries on Earth, like Luxembourg or Malta. But don't let their size fool you. These moons are anything but ordinary. One of the most shocking things about Phobos and Deimos is their shape. Unlike our moon, which is a near-perfect sphere, these Martian moons are irregular and lumpy, resembling giant potatoes more than celestial bodies. Why is that? It all comes down to gravity, or rather, the lack of it. Their gravitational pull is so weak that they can't pull themselves into a spherical shape. Instead, they remain jagged and uneven, a constant reminder of their chaotic origins. And speaking of origins, the story of how Phobos and Deimos came to orbit Mars is nothing short of astonishing. The most widely accepted theory is that these moons were once part of the asteroid belt, a vast ring of rocky debris located between Mars and Jupiter. Billions of years ago, the massive gravitational force of Jupiter likely kicked these asteroids out of their orbit, sending them hurtling through space. Mars, with its own gravitational pull, eventually captured them, turning them into its permanent companions. But here's where things get even more intriguing. Some scientists believe that Phobos and Deimos might not be captured asteroids at all. Instead, they could be the remnants of a much larger moon that was shattered in a catastrophic collision. Imagine that, a single massive moon torn apart by a violent impact, leaving behind only these two fragments. The truth is, we still don't know for sure, and that's what makes these moons so captivating. Now let's talk about Phobos, the larger and more mysterious of the two. Phobos orbits Mars at an incredibly close distance, just 9,400 kilometers above the planet's surface. To put that into perspective, our moon orbits Earth at an average distance of 384,400 kilometers. Phobos is so close to Mars that it completes an orbit in just 7.5 hours. That means it whips around the planet 3 times a day, racing across the Martian sky like a speeding bullet. But here's the shocking part. Phobos is on a collision course with Mars. Every year, it gets about 2 meters closer to the planet. In 50 to 100 million years, Phobos will meet its fate. It will either be torn apart by Mars's gravity, creating a stunning ring of debris around the planet, or it will crash directly into the surface in a cataclysmic explosion. The energy released from such an impact would be unimaginable, enough to wipe out any life on Mars and reshape the planet's surface forever. If humans are living on Mars by then, they'll need to build some seriously strong bunkers to survive. But what about Deimos? While Phobos is hurtling toward its doom, Deimos is slowly drifting away. This smaller moon orbits Mars at a much greater distance, about 23,460 kilometers, and it's gradually escaping the planet's gravitational pull. In a few 100 million years, Deimos will break free from Mars entirely, leaving the planet moonless and alone. Imagine that. A lonely red planet, stripped of its companions, drifting through the cold emptiness of space. It's a haunting thought, one that reminds us just how dynamic and ever-changing our solar system truly is. But the mysteries of Phobos and Deimos don't end there. These moons are also home to some of the most bizarre and unexplained features in the solar system. Take Phobos, for example. Its surface is covered in deep grooves and strange linear patterns that scientists still can't fully explain. Some believe these grooves are the result of tidal forces, the same forces that are slowly pulling Phobos apart. Others think they might be the remnants of ancient impacts, scars left behind by collisions with smaller asteroids. And then there's the Stickney crater, a massive impact crater that dominates Phobos's surface. This crater is so large that it nearly shattered the moon when it formed. The impact would have sent shock waves rippling through Phobos, creating the grooves and fractures we see today. It's a reminder of just how violent and chaotic the early solar system was. Deimos, on the other hand, is a bit of a mystery in its own right. Unlike Phobos, Deimos has a much smoother surface, covered in a thick layer of dust and debris. Scientists believe this dust might be the result of micrometeorite impacts, which have slowly eroded the moon's surface over billions of years. But what's truly fascinating about Deimos is its orbit. Unlike most moons which orbit their planets in a relatively flat plane, Deimos has a highly inclined orbit. This means it moves above and below Mars' equator, creating a unique and unpredictable path through the sky. It's just one more piece of the puzzle that makes these moons so intriguing. And then there's the question of life. Could Phobos and Deimos hold clues to the existence of life on Mars? Some scientists believe that these moons could serve as time capsules, preserving evidence of ancient Martian life. If Mars once had liquid water and a thicker atmosphere, as many scientists believe, then it's possible that microbial life could have existed on the planet. Over time, impacts from asteroids and comets could have blasted pieces of Mars' surface into space, some of which may have landed on Phobos and Deimos. These fragments could contain traces of ancient Martian life, waiting to be discovered. It's a tantalizing possibility, one that could revolutionize our understanding of life in the universe. But perhaps the most shocking thing about Phobos and Deimos is how little we know about them. Despite decades of study, these moons remain shrouded in mystery. We've sent probes to Mars, explored its surface, and even landed rovers to search for signs of life. But Phobos and Deimos have largely been overlooked. Only a handful of missions have been dedicated to studying these moons, and none have landed on their surfaces. That's why scientists are so eager to learn more. Future missions, like the proposed Phobos Surveyor, could finally unlock the secrets of these enigmatic moons. By studying their composition, structure, and history, we could gain new insights into the formation of Mars, the early solar system, and even the potential for life beyond Earth. So what does the future hold for Phobos and Deimos? Will Phobos crash into Mars, creating a spectacular ring of debris? Will Deimos escape into the void, leaving Mars behind? Or will we uncover even more shocking secrets hidden beneath their surfaces? The truth is, we don't know. But one thing is certain. These moons are more than just rocks in space. They're windows into the past, clues to the origins of our solar system and perhaps even keys to understanding life itself. The story of Phobos and Deimos is a story of mystery, discovery, and the endless quest for knowledge. And as we continue to explore the cosmos, these tiny moons will remain a reminder of just how much we have yet to learn. In the end, the tale of Phobos and Deimos is a reminder of the fragility and dynamism of our universe. These moons, born from chaos and destined for destruction, are a testament to the ever-changing nature of the cosmos. They remind us that nothing in space is permanent, that even the most seemingly stable objects are subject to the forces of time and gravity. And as we look up at the night sky, we can't help but wonder, what other secrets are waiting to be uncovered? What other mysteries lie hidden in the vast expanse of space? The answers are out there, waiting for us to find them. And who knows, maybe one day we'll finally unlock the secrets of Phobos and Deimos, and in doing so, uncover the true story of Mars and its place in the universe. The mysteries of Phobos and Deimos go far beyond their origins and their eventual fates. These moons are not just silent spectators in the Martian sky, they are active participants in the ongoing drama of the solar system. Recent discoveries and cutting-edge research have revealed even more shocking details about these enigmatic bodies, details that could rewrite our understanding of Mars and its history. Let's dive deeper into the latest revelations and explore why Phobos and Deimos continue to captivate scientists and space enthusiasts alike. One of the most groundbreaking discoveries in recent years involves the composition of Phobos and Deimos. For decades, scientists believed these moons were made of the same material as asteroids, rocky, carbon-rich bodies from the asteroid belt. But new data from missions like NASA's Mars Reconnaissance Orbiter and the European Space Agency's Mars Express have challenged this assumption. Spectroscopic analysis of Phobos' surface has revealed that its composition is strikingly similar to that of Mars itself. This has led to a radical new theory. Phobos and Deimos might not be captured asteroids at all. Instead, they could be the remnants of a massive impact on Mars, similar to the one that created Earth's moon. Imagine a colossal collision billions of years ago when a giant object slammed into Mars, ejecting debris into orbit. Over time, this debris coalesced to form Phobos and Deimos. If this theory is true, it means these moons are not alien visitors, but born and bred Martian natives. This revelation has sent shockwaves through the scientific community, forcing us to rethink everything we thought we knew about these moons. But the surprises don't stop there. Phobos, in particular, has been the subject of intense scrutiny due to its unusual behavior. As it orbits Mars, Phobos experiences extreme tidal forces. These forces are so powerful that they are literally tearing the moon apart. Scientists have observed massive cracks and fractures on Phobos' surface, evidence of the immense stress it's under. Some researchers believe that Phobos is not a solid body at all, but a loose collection of rocks and dust held together by gravity, a so-called rubble pile. This would explain why it's so fragile and why it's slowly disintegrating as it spirals closer to Mars. The idea of a moon being torn apart by its own planet is both terrifying and awe-inspiring, a stark reminder of the raw power of gravity. And then there's the mystery of Phobos' grooves. These strange parallel lines crisscross the moon's surface, creating a pattern that has baffled scientists for decades. Initially, it was thought that these grooves were caused by impacts, but recent studies suggest a more dramatic explanation. Some researchers believe that the grooves are the result of tidal forces, the same forces that are pulling Phobos apart. As the Moon gets closer to Mars, the planet's gravity stretches and deforms it, creating stress fractures that manifest as grooves on the surface. Others have proposed that the grooves are the result of boulders rolling across the surface after being ejected from the Stickney crater, Phobos's largest impact feature. Whatever the cause, these grooves are a haunting reminder of the Moon's turbulent past and its uncertain future. Deimos, on the other hand, has its own set of mysteries. While it may not be as dramatic as Phobos, Deimos is no less fascinating. One of the most puzzling aspects of Deimos is its surface, which is covered in a thick layer of dust and regolith. This dust is thought to be the result of micrometeorite impacts, which have pounded the Moon's surface for billions of years. But what's truly intriguing is the possibility that this dust could contain material from Mars itself. If Mars once had a thicker atmosphere and liquid water, as many scientists believe, then impacts from asteroids and comets could have blasted pieces of the Martian surface into space. Some of this material may have landed on Deimos, embedding itself in the Moon's dusty surface. If we could analyze this dust, we might find clues about Mars's ancient climate and even evidence of past life. It's a tantalizing possibility, one that has scientists eager to send a mission to Deimos. But why haven't we explored these moons more thoroughly? The truth is, Phobos and Deimos have been overshadowed by Mars itself. For decades, the focus has been on the Red Planet, with missions like the Mars rovers and the Mars Reconnaissance Orbiter capturing the public's imagination. But that's starting to change. In recent years, there has been a renewed interest in Phobos and Deimos, driven by the realization that these moons could hold the key to understanding Mars' history. Several missions are currently in the planning stages, including the Japanese Aerospace Exploration Agency's JAXA Martian Moons Exploration (MMX) mission, which aims to land on Phobos, collect samples, and return them to Earth. This would be the first time we've ever brought material from a Martian moon back to our planet, and it could revolutionize our understanding of these enigmatic bodies. The MMX mission is particularly exciting because it could finally answer the question of whether Phobos and Deimos are captured asteroids or the remnants of a Martian impact. By analyzing the composition of Phobos's surface, scientists hope to determine its origin once and for all. If the samples contain material that matches Mars' crust, it would provide strong evidence for the impact theory. On the other hand, if the samples are more similar to asteroids, it would support the idea that these moons are captured objects. Either way, the results will have profound implications for our understanding of the solar system. But the exploration of Phobos and Deimos isn't just about science. It's also about the future of human space exploration. These moons could play a crucial role in our efforts to colonize Mars. Phobos, in particular, has been proposed as a potential staging point for missions to the Martian surface. Its low gravity and close proximity to Mars make it an ideal location for a space station or fuel depot. By establishing a base on Phobos, we could reduce the cost and complexity of missions to Mars, making it easier to transport people and supplies to the planet. Some scientists have even suggested that Phobos could be mined for resources, providing water and other materials for future colonies. It's a bold vision, one that could transform Phobos from a scientific curiosity into a vital hub for human exploration. And then there's the emotional aspect of these moons. Phobos and Deimos are more than just rocks in space. They're symbols, of the enduring mystery and beauty of the cosmos. They remind us that there is still so much we don't know, so many secrets waiting to be uncovered. Every time we look at these moons, we're reminded of the vastness of the universe and our place within it. They inspire us to keep exploring, to keep asking questions, and to keep pushing the boundaries of what we think is possible. So what does the future hold for Phobos and Deimos? Will we finally unlock their secrets, or will they continue to elude us? Only time will tell, but one thing is certain. These moons will remain a source of fascination and wonder for generations to come. As we continue to explore the solar system, Phobos and Deimos will stand as a testament to the enduring mystery of Mars and the limitless potential of human curiosity. The story of these moons is far from over. In fact, it's just beginning. And who knows what shocking discoveries await us as we venture deeper into the unknown. The answers are out there, waiting to be found. All we have to do is keep looking.